Yeah,
Yes. So today we want to learn about another sensor. Sensors. Remember we discussed about light and humidity, temperature sensor. Sorry. Will can you see this?
yeah,
Yes. And the humidity. We saw how to run it. You click there. Today it's running quite fast. Okay. And can you see the lux is the light intensity? And then we said you click here and then you can be able to increase this. Do you see?
yeah.
Okay. Okay. And then you can be able to see the light intensity. So if you have the actual hardware, this code will work. Okay. And we did something here. Uh, we said that if you check the code, that if the light intensity, do you see this part of the code? Do you see?
Yes, yes.
Yes, I can actually share with you the latest code with even the motor. 1 minute, I share with you. I share with you. Can you check the chat? Do you see the chat? It on the chat?
Yeah.
Yes. So you can just open that. So we were checking here that if the light intensity is 500, then we turn on the red LED. Do you see the red? The red LED was here. Okay. Can you see?
Yes, yes, yes.
Yes, yes. So you run it, and then so the values here is around 250. So when you click this and then you increase it to around 900. Do you see the red LED is on? Yes.
Yeah, yeah, yeah.
And then if you do it around there, do you see it's turning off or turning on and turning off? Okay. Can you see that?
Yes, yes.
Actually, you could even do something fun here. You can decide that if it is on, then the green LED, it is safe. So here we would say, like, if the temperature is very low, then it is safe. Green normally shows safe. So green, what will we turn? What will we say here? Green will be low, isn't it?
Yeah.
And then when it is above that, so when it is off, then
It's
this
high.
yellow, then the green will be high, isn't it? Okay. Yeah.
Yeah, yeah.
So you can run it again. I hope it will not delay us, but you understand the logic. The when it is high, when it is above 500 lux, the lux of 500, then change that. It's giving us some problem. It's not supposed to be. Oh, we didn't have green LED, red LED
That,
space. Okay, we just had red copy. Mm, yes, green. Okay. And you remember green, we put green on number. Remember green? Green is number two. Can you see that?
yeah, yeah.
Yeah, so here we say here is two. And then green LED, red LED, the pin mode and their output. So you copy and then you paste there. Copy the red, Control Z. You copy this, Control C, and then you put it here. and then you change here to green, isn't it? Okay.
Yeah.
Yes. And normally it's good to put comment, but you now know how to add comments. Like here now you can even say that LEDs as output. You can put a comment like that. And then here you put comment buttons as input pull up. Okay. So that is how to put the comment. And then here you say, like the loop here, read the light intensity. And then here you say that check if light intensity. Here you say check if light intensity is above 500 lux. Do you see that? Yes?
Yes.
Yes, yes. So green LED, green LED. So now you can save and then that. Okay. You'll be able to work. While it is running, I want to show you the stepper motor. You see the stepper motor we looked at. This is how to connect it to its motor driver. So it's still busy showing us that error. So this is the stepper motor. It has got four wires. One A minus. Did you see this A minus?
Yeah.
Then A plus. Okay.
Yes.
Then B plus and B minus. Okay. Do you see that?
Okay.
So they come to, so A and this, they come together, this one. We have 2B and 1A, then 1A and 1B. So you can decide to put them, you put them together to this one. 2B and 2A. So you put them together to this. This other one is ground, this one is power. So, but the two important one is this and this. Do you see this?
Yes.
You connect them to these two, and then this other one you connect to these two. Then down here, there are other pins. The step is used to drive one step, and then the other one, sleep, is used to stop it from working. Step is to make it run, and then sleep is to used to stop
Stop.
it. Okay. Yeah. So the challenge to you, we are going to start by doing it. The challenge to you is that we do the programming of this thing. And then when somebody presses one of this button, then the motor turns. Okay?
Okay.
Yeah, but I'll show you. This is for the stepper motor. And this is how, have you seen the connection is the same to this? Isn't it?
Yes.
Aye. Then here, this and this have been connected to pin. Do you see this pin 9 and pin
Mm.
8?
Eight.
Pin 9 and 8, isn't it?
Yes.
Yeah. So there, it has been connected to pin 9 and 8. So those are the two here. We have got the direction pin. The direction is where you want it to go clockwise or anti-clockwise. Okay. Do you see that?
Yeah.
And then the step pin is where you are going to send it, the steps to go, how many steps you want it to go. Like if it is rotating, then it makes one step of several degrees. And then this is the number of steps. It is rotating, or the number of, if you want it to rotate, then there is an LED, then there is a button on pin 2. The button is here. Do you see this button? You see this button has been connected to pin 2.
Yeah.
Yeah. The button has been connected to pin 2 there. Then we have pulse width microseconds and steps microseconds. Then start, there's a function, there is a variable there called start. And then we said serial.begin is used to print something to the, do you see here? Do you see here? To the screen. Do you see? Here,
Yeah.
we are starting the motor test. Okay, so that is where the serial print is used. And then we have LED as output, direction, pin, and all that. This one is used to initialize the stepper motor. Do you see that? This one,
Yes.
these two are important, the direction pin and the output pin. Do you see those? Pin 8
Yes.
and pin 9. Okay.
Yeah.
Okay, then here we are checking if the digital pin button is pushed, meaning if you push the button, then digital write, we are sending the command, we are sending for it some, you are turning on the stepper pin, and then you are sending the number of steps you want it to run. So this is how you do the turning on of the motor. Are we together? Are we together?
Yes.
Yes, and then here is how to turn it off. Okay? Are we together?
Yes. Yes.
Yes, so I'm going to share with you this code. I'm going to share with you this code after the class, and then you click stepper motor. Do you see it is running? Can you see?
Yeah.
So if we click here, then it
Okay.
rotates. This is the steps. The
Rotate.
steps is this one, 81, 82, 83, the angles. Okay.
Okay.
Yeah. So if it goes up to the last, and the maximum is normally 360 degrees, isn't it? From zero, when it rotates one full cycle, is 360 degrees, isn't it?
Yes.
And then it goes back to the negative direction. Okay. And if you click it again, it should, when you click it, it goes one full cycle, and goes back. Okay. Have you seen that?
Yes.
Yes. So the challenge to you is going to be to do this. And let's just try to start doing it. So there are these two pins, direction. There is direction, number of steps. This is how, in coding, you normally copy from what other people have done and then you modify. We have the direction, stepper pin, and number of steps. Do you see that? Yeah? You see that? Can you see that?
Yes. Yes.
Yes. So you write it down. You write it down here. Like you say, you put a comment, stepper, motor. So you have here. Okay, the direction pin. The direction pin is this. If you come here, there is the sleep and then there is step. So there's direction pin from this one. Which one is the direction pin? Pin 8. Do you see this pin 8? Do you see this? DIR. Okay.
Yes.
So, or in short, it is this first one. Okay. So this first one, it goes to pin number 20.
21.
Yeah. So what do we do? We change here to direction pin to 20, 21. Do you see that? Yeah.
Yeah.
And then the step pin, the step is pin 22. The step is pin 20, 22. But actually, the correct thing is you should connect it to a pin which has something called pulse width modulation. So let me look for Raspberry Pico pin out. We already looked at this last week. Do you remember this diagram? Raspberry Pico pin out. Do you remember this diagram?
Yes, yes.
Yes. So I want you to look for the one which is called PWM, the one which has something called pulse width modulation, PWM. PWM. Because that is the one which
Nowhere.
is nowhere. Okay, we can always.
There's a key there, but she wasn't there.
Okay, let me say you can search Raspberry Pico PWM. So PWM, I don't want you to worry about it now. It has got some physics, some kind of engineering about it. I don't want you to worry much about it. But the PWM pin, GPIO 20. Do you see GPIO 20? Do you see
Yes.
GPIO 20? It is a PWM pin. Okay. GPIO 20. Okay. So let's come here. Have we connected GPIO 20? Can you see GPIO 20? 20.
Okay, to your left, to your left.
20, isn't
Yeah,
it?
yeah.
So this one is the one which we should use to connect the GPIO. Okay. There was this other one. We were connecting GPIO. We connected pin 22. This one is pin 22. Should delete this and instead connect pin 20. Do you see this?
Yeah.
So GPIO 20 is the one which should be there. That's clear now?
Yes.
Yeah. So here it should be GPIO 20. Okay. Up to there we are together.
Yeah.
Okay. Then the next thing that we do is we need to so we have connected, we have the steps pin. Then they have got this pulse width microseconds and milliseconds between steps. This and instant. So this has used delay, millisecond between steps, and then if that one. So this is also important. You also copy this part, these three. Do you see those three? Do you see microseconds between and milliseconds between start? You can put them, hard code them, but I'm just going to put them there nicely. We will use these three variables. They are called variables. Microseconds, and that one, and that one. Okay. Are we together?
Okay.
Okay.
Yeah.
Yeah. So that is how we do it. And then the next thing is here you have stepper motor. The printing is not important, but the most important thing is we have these three. Do you see the direction pin?
Step pin and the
Step
line
pin.
pin.
Yes, they are being put as output. And LED we don't need. Step pin and
Direction pin.
yes. So that is how we do that. So this other one, you see here, you have done it very well now for button. And then here you come and say what? Stepper motor pins. Do you see that? Do you see?
Yes.
Yeah, so that is the stepper motor pins. And you from here, you can, even you, if I give you this code, you will see this guy, the LED pins are here. Then the button pins are here. Do you see? And then the stepper motors are here. You see that? And then this other one, you can say the light sensor pin. See that? Can you able to see that, Leslie?
Yes, I can see it.
Yeah, so this is how you comment your work neatly, and by connecting it, you will be able to, somebody else will read this code, will understand. So we have set up the stepper motor, and then here, finally, how the stepper motors are running, that if the button pin, it starts here. If button pin is this low, then digital right, you do all that, direction pin, and then you do a delay. So let's just see this. Let's just copy this part up to here. Okay, do you see that? So
Yes.
in the loop, you can check it, you can put it anywhere, but let's check after we have checked this button read. That is button read, and then light intensity, we have done the button read. Where's the place where we were checking the temperature, the light intensity? We've done the light intensity. We check that, and then we do this. So maybe we do it here. We say the control motor. Okay, do you see that? Do you see that? Do you see it?
Yes.
Okay, and then we want to control it with the green button. Okay, we want to control it with the what? With the green button, isn't it?
Yes.
Yes. So if we click the green button, then inazunguka. Okay, let us pray to the gods of this walkway so that it runs. Okay. So let me also share with you the code up to here, then you can also try it on your side. Already there are some errors, but that's something we can fix. Can you check the chat? Can you check the chats?
Yeah.
Okay, it was saying some errors here.
I tried on my side.
Yes, try it from your side.
Yes. Immediately the build failed.
So you read this LED. You see this LED in the loop. There was this LED. You see this LED. We don't need it. We are not using any LED. Okay. You see that? We didn't need any that LED. Or unless if you want to turn on the other LED.
I delete the whole sentence. The whole
Yeah, just comment it out for now.
for now.
Taking some time to compile, but I hope your side it will. So if you have actual hardware, then it compiles very quickly. Then there is also, and I expected that at the end of input. Okay. Okay, this was being closed by this. Oh, there was a semicolon we left here. Okay, it's not a semicolon but quotation. So those are the small errors which, when you copy code or when you learn how people have done it, then you will just fix them as you solve your problem. Okay, it's telling me the server is busy. Okay.
Mine also said servers are busy.
Yeah, so I go and run this, and then we should be that when you press this one, then the button is the what? The stepper motor is going on. It's going. Do you see that? Okay.
Yes.
Okay, so there is something here that I want you to teach you, something called functions. You can say, do you see this motor control
Yeah.
here? Here up to here,
Yes,
this
yes.
this part of code up to here. Do you see this?
Yeah, yeah.
We
Yes.
can cut it, Control X. Okay. Then we create something called a function. So you say void run motor. You say run motor. Do you see that? Do you see that? Void run motor. You remember how we were writing a function in Python. In Python, you were saying def, maybe run motor. Do you remember in Python we were doing this? Do you remember
Yes.
how? And then we were writing maybe print hello. Do you remember how we were doing that in Python? So in C++, you do it like this, void run motor, and then you come here, you paste this here. Do you see the all of this? Okay. This is used to run the motor. Do you see?
Yeah.
Yeah, so you put it inside that. Then instead of where you need to run the motor, you say you copy this, and then you say if digital write the green button, what do we do? We run motor. Do you see that?
Yes.
Yes. So it has made your code clean. Do you see? It has made your code clean. And then before this works, before the setup, you need to do something called, or after setup, normally you can put it before setup, you say void run motor, like that, motor, and then you just do empty, like that. So that is called function prototype. You will learn this when you learn C++ in depth. I think you must be taught C++ when you are doing mechatronics. So this is called a function prototype. You run it, you put it on top of the function there, or the top of the setup, and then you come down here. Then you say void run motor, and it must have the same name. And then you do everything that was running the motor. And then when you need to call it, now here you say digital write, read. If there's digital write, read motor, then it run motor. Do you see? Do you see?
Yes.
Do you see that?
Yeah.
Yes, but then you can also copy this. Now you see run motor is very simple. When we were testing the temperature, do you see this light intensity? If light intensity is above 500, do you see? Eh?
Yes.
Then if it was above intensity, then we need to do what? To run the motor. Can you see that? Can you see?
Yes, yes.
Yes, yes. So that's how to write clean and what is called reusable code, because now this is code which you can reuse. This part of code you need to now have it and reuse it. Okay, we have some few minutes, so I want you to also do this. This is called DHT. Do you see this?
Yes.
It will print, this one will print for us the temperature. It is a sensor. It's what we were supposed to learn. Sensor which will print for you temperature and humidity. It is called DHT22. So this is how to connect it. It has three, this one you connect ground, and then you connect this pin. It's called SDA. This one is the data pin. You connect it to the pin which you want to connect, and then this other one is power 3.3. So for here, we have connected it to pin A0. Can you see pin A0? Can you see?
Yes.
Yes, so that's why we have we've done that. So then this is how you initialize it. It has its library. I told you just import the library and then you put that it is DHT22. And these are part of the library. These ones you just copy from this reference code. You don't need to worry about understanding what they do. What you are just doing is that you are connecting it to A0, and then this one is how to use the library. And then you initialize the sensor by saying DHT.begin. And then, so you have temperature. Do you remember temperature we said is a float? Because it has decimal. Do you see?
Yes.
And humidity. So they are float, and then you read them. You read temperature, float T is temperature.read, and temperature humidity.read. And then you print. Serial.print. Sio ni rahisi? Isn't it?
Yeah.
Yeah. So see. Can you see?
Yeah.
And if you click on it, you can change these values. And then you will
Temperature.
see them changing. Isn't it?
Yeah.
Yeah. So a challenge will be for you to include DHT here. How do we include? We say DHT22. Sindio hiyo?
Yes.
Okay. And then it's easy. We start with the ground. Connecting ground is easy, isn't it?
Yeah.
Okay. And then VCC is power.
Mm. Mm.
Also is easy, isn't it?
Yeah.
It's easy. And then the remaining one, you connect to any of the pins. You can use any, like GP7. Okay. Can connect to any of the pins. SDA is the data pin. So you come here, GP11, any of this which is blank, GP7. Do you see that?
Yeah.
Yes. Then I want you to edit the code to include that sensor value. So you type it, you print it here. Okay. Okay. Is that okay, Leslie?
Yes. Yes.
Yes. So do that for today. That will be when we review it. It will mark the end. We shall have finished this electronics, how to run electronics using this, because we have coded button, we have coded LEDs, we have coded screen, we have coded motor, we have coded the temperature sensor, light sensor, and everything. You see how long our code is. Actually, it's very impressive. Okay.
Yes.
Yes.
Okay.
Yeah. So did mom buy those things, or she's not buying?
I'm not sure. I'm sure
Uh,
she'll buy.
mm,
I can try to convincing her, but it's also a lot of stress trying to get.
no, now